Imagine a sweltering hot day. You crave a cold drink. You open the refrigerator door, and cool air rushes out. Inside, a bottle of juice is perfectly chilled. But how does this magic box stay so cold? A refrigerator does not actually create cold. It is a heat mover. Its job, take heat from inside the box and move it to the outside. This clever trick runs in a hidden cycle. It runs day and night, keeping your food fresh and your ice cream frozen. This process is called the refrigeration cycle. It uses a refrigerant that travels through a closed loop of pipes. Think of the refrigerant as a tiny heat-collecting sponge. It soaks up heat from inside the fridge, then gets squeezed to release that heat outside. This cycle involves four main parts: compressor, condenser, expansion valve, evaporator. When you sweat on a hot day, you cool down as the sweat evaporates. Evaporation uses heat from your body. A refrigerator works on the same principle, but in a controlled, powerful way. It forces a fluid to evaporate inside the fridge to absorb heat and then forces it to turn back into a liquid outside to release that heat. It's a continuous loop of changing states, from gas to liquid and back to gas, all designed to transport unwanted warmth away from your food. Let's look at this amazing journey. The refrigerant starts as a cool, low-pressure gas. The entire system is sealed, so the same refrigerant is used repeatedly, constantly moving through hidden pipes. The cycle begins at the heart of the system, the compressor. This part is usually a black, dome-shaped motor at the back of the fridge, near the bottom. Its one and only job is to squeeze the refrigerant. The refrigerant arrives at the compressor as a cool gas at low pressure. The compressor, powered by electricity, acts like a powerful pump. It draws the gas in and compresses it into a much smaller space. This is a bit like pumping air into a bicycle tire. As you force more air in, the pressure inside increases, and the pump itself can get quite warm. When the compressor squeezes the refrigerant gas, two things happen. First, its pressure goes way up. Second, its temperature skyrockets. The gas that was cool just moments ago is now a very hot, high-pressure gas. This step is crucial because to get rid of heat, the refrigerant needs to be hotter than the air in your kitchen. You cannot move heat from a cold object to a hot object without doing some work. The compressor does that work. It adds energy to the refrigerant, getting it ready for the next stage where it will dump all this newly acquired heat. You can often hear the compressor working. It is the low humming or buzzing sound your refrigerator makes when it kicks on. When you hear that sound, you know the refrigeration cycle is in full swing. The hot, pressurized gas is being pushed out of the compressor and into a series of pipes. This energy-intensive step is the main reason your refrigerator uses electricity. It takes a lot of effort to put that much pressure on a gas, but without this, big squeeze, the entire cooling process simply would not work. The refrigerant would not be hot enough to release its heat. The hot gas, now under immense pressure, leaves the compressor and begins its journey toward the next component in the loop. It has absorbed a lot of energy, both from the work the compressor did and from the heat it will eventually pick up inside the fridge. Its state is still a gas, but a very energetic and unstable one. It is desperate to release this energy and cool down. The next part of the system is perfectly designed to help it do just that, using the simple air in your kitchen as a partner in the process. Now that the refrigerant is a hot, high-pressure gas, it flows into the condenser coils. These are the large, winding coils of pipe you can see on the back of many older refrigerators, or hidden within the walls of newer models. The purpose of the condenser is to get rid of the heat the refrigerant is carrying. As the hot gas travels through these coils, it is exposed to the cooler air of your kitchen. Heat naturally moves from a hotter object to a cooler one, so the heat flows from the refrigerant gas into the surrounding air. This is why the back of your fridge often feels warm. As the refrigerant loses its heat to the kitchen air, something amazing happens. It changes state. It condenses from a hot gas into a hot liquid, much like steam condenses into water on a cool bathroom mirror. This process of condensation releases a large amount of energy. The refrigerant is now a high-pressure liquid, but it is much cooler than it was when it left the compressor. The condenser coils often have fins attached to them to increase the surface area, making it easier and faster for the heat to escape into the air. Next, this high-pressure liquid moves to the expansion valve. This component is a tiny bottleneck in the plumbing, a very small opening that the liquid refrigerant is forced to squeeze through. When the liquid passes through this narrow passage into a larger area of pipe, its pressure drops dramatically. Imagine letting the air out of a balloon. It rushes out from high pressure to low pressure. This sudden drop in pressure causes the liquid refrigerant to cool down instantly, becoming extremely cold. A portion of the liquid even flashes into a gas, which cools it down even further. This step is the key to creating the cold. The refrigerant is now a very cold, low-pressure mixture of liquid and gas. It has gone from being hot to being frigid in just a few feet of tubing. The expansion valve does not remove heat, but it cleverly manipulates the pressure to drastically lower the refrigerant's temperature. The super-chilled, low-pressure refrigerant now flows into the evaporator coils. These coils are located inside the freezer or refrigerator compartment, hidden behind a panel. This is where the actual cooling of your food happens. The air inside your fridge circulates around these coils. It's warmer than the cold refrigerant, so heat moves into the refrigerant. The heat from your food, the heat from drinks, and the warm air that entered when you opened the door are absorbed by the refrigerant. As the cold liquid refrigerant absorbs heat, it begins to boil and turn back into a gas. This process is called evaporation. Like water boiling on a stove, the refrigerant needs heat to change to gas. It pulls that energy from the air, leaving the air much colder. The journey begins again. The gas carries the absorbed heat with it. At the compressor, it will be squeezed, then heated up, and finally sent to the condenser to release heat outside. This continuous loop keeps the inside cold. Compression, condensation, expansion, evaporation. A thermostat inside the refrigerator senses temperature. If it detects the inside has warmed above the set point, for example, you opened the door too long, it signals the compressor to start the cycle. Once cool enough, the thermostat shuts the compressor off, saving energy. This on and off action keeps a stable, cold environment day and night. The refrigeration cycle is a robust process, but it works best when the components are well maintained. The condenser coils, in particular, play a vital role in releasing heat. If they are covered in dust, pet hair, or other debris, they cannot release heat efficiently. It is like trying to cool off while wearing a wool coat. The compressor has to work harder and run longer, which wastes electricity and can shorten the lifespan of your appliance. A simple practical tip is to clean these coils once or twice a year with a vacuum or brush. It is also important to be mindful of the refrigerant itself. In older refrigerators, the refrigerants used were chlorofluorocarbons, hydrochlorofluorocarbons, which were found to be harmful to the Earth's ozone layer. Modern refrigerators use more environmentally friendly refrigerants, like hydrofluorocarbons, hydrocarbons. However, all refrigerants are potent greenhouse gases if they leak. For this reason, you should never try to repair a refrigerant leak yourself. This is a job for a trained technician who can safely capture, recycle, and recharge the refrigerant. To help your refrigerator's cycle run efficiently, make sure there is enough space around the refrigerator for air to circulate freely, especially around the back and top where heat is released.